Hello friends, welcome back to my channel. Today I will start glycogenesis process. Firstly I say glycogen metabolism. Glycogen. Glycogen is a polysaccharide-like starch present in the animal body. It is composed of several glucose units joined by 1,4 linkage in straight chain and 1,6 linkage at branch point. Thus, glycogen is highly branched polymer of glucose. So mainly glycogen is present in the liver, muscle, in animal body. Glycogen is not only the store from glucose but is also an excellent reserve energy stores. So glycogenesis. Glycogen is synthesis using glucose molecule in both skeletal muscle and liver. Glycogen is synthesis using the monosaccharide units. In the skeletal muscle and in the liver, there is a protein molecule known as glycogenin, which is the carriers of the entire molecule. This glycogenin carries a glycogen primer on which the glycogen molecule is synthesized. In the liver, the glycogen protein is present in one site on that of which glycogen primer is present. But in skeletal muscle, the glycogenin remains at the entire on both sides of which the glycogen primer is present. In the first step, glucose is first converted to glucose 6-phosphate by enzyme hexokinase. So first I draw glucose structure and glucose structure is the very easy structures. So the enzyme hexokinase that converted to glucose 6-phosphate, in this reaction ATP is enters and produce ADP and Mg2 plus and Mn2 plus cofactor. The whole reactions helps to maintain reactions hexokinase enzyme. Again, in the second step, glucose 6-phosphate is now converted glucose 1-phosphate by using phosphoglucomutase. So I have presented glucose 6-phosphate structures and it is converted as glucose 1-phosphate and for enzyme of phosphoglucomutase. So the phosphate group of mutations 6 carbon of phosphate group transfer first carbon of H transfer 6 carbon. So that is the mutations, the phosphoglucomutase helps in this reaction. In the third step, glucose 1-phosphate is now converted to UDP glucose. So, by using one UTP molecule, that is a UTP molecule. So, UTP molecule is first made to react with glucose 1-phosphate. So, UTP molecule first react with glucose 1-phosphate by enzyme uridine transferase enzyme. Uridine transferase enzyme which eliminates pyrophosphate molecule during the reactions. So converted UDP glucose is the active form of glucose. UTP uridine triphosphate and UDP full from uridine diphosphate. In the fourth step, so first glycogen primer draw and glucose molecule. Glucose forming UDP glucose is an important step since UDP glucose is the active glucose molecule. The UDP glucose joins with the last glucose residue forming 1,4 linkage and UDP is released. So this 1,4 linkage is created by using glycogen synthesis enzyme. And our projections of glucose molecule that branch of 1,4 linkage, that 1,4 linkage create to the 1,4 linkage. Step 5. Branch. So similarly, I have presented glycogen in protein and glucose primer. So in this step, branching enzyme breaks off a part of the nearly glucose chain and shift it to another neighboring glucose residue. The enzyme creates 1,6 linkage rise to a branch point is an glycogen molecule. So thus the glycogen contain 1,4 linkage in a straight chain. So thus the glycogen contain 1,4 linkage in a straight chain and 1,6 linkage branch point. Okay.